Hey everyone, welcome back to the channel. In this video, we're breaking down the constant acceleration equations. First with a clear explanation, and then we'll solve a few problems together. Let's dive in. What is constant acceleration? Constant acceleration means the rate of change of velocity stays the same. For example, free fall under gravity, ignoring air resistance, has a constant acceleration of 9.8 meters per second squared. To understand and solve problems involving constant acceleration, we first need to know what quantities we're working with. So before we dive into solving, let's get familiar with the core variables behind motion. To use these equations, we track 5 key variables: initial velocity, final velocity, acceleration, time, and displacement. Now that we know the variables, let's see how they come together in the equations of motion. Equation 1. Final velocity equals initial velocity plus acceleration times time. This equation gives us the final velocity after an object accelerates over a period of time. It's perfect for questions where you're given the initial velocity, the acceleration, and the time. Equation 2, displacement equals initial velocity times time plus 1/2 times acceleration times time squared. This one gives you the displacement when you know how long something has been accelerating. It's especially useful when tracking how far something has traveled over time with constant acceleration. Equation 3, final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. This equation skips time altogether. It's your go-to when you want to find the final velocity. But time isn't given, only how far it traveled and how fast it was going at the start. Equation 4. Displacement equals initial velocity plus final velocity divided by 2 times time. This version uses the average of the starting and final speeds to find displacement. It's a handy shortcut when you know both velocities and the time. Problem 1. A car starts from rest and accelerates at 2 meters per second squared for 6 seconds. How far does it travel? We're given initial velocity 0. Acceleration is 2 meters per second squared. Time is 6 seconds. We're looking for displacement. We'll use the equation. Displacement equals initial velocity times time plus 1/2 times acceleration times time squared. Substitute the values. X equals 0 times 6 plus 1/2 times 2 times 6 squared. That simplifies to x equals 0 plus 1 times 36. So, the displacement is 36 meters. The car travels a total of 36 meters in 6 seconds. Problem 2. A ball is thrown straight up with a velocity of 20 meters per second. How long until it reaches its highest point? Let's identify what we know. The initial velocity is 20 meters per second, upward. At the highest point, the final velocity is 0, since the ball momentarily stops before falling back down. And the acceleration is negative 9.8 meters per second squared, due to gravity. We'll use the equation v equals initial velocity plus acceleration times time. Substitute the values. 0 equals 20 plus negative 9.8 times time. Now solve for t. Subtract 20 from both sides. We get negative 20 equals negative 9.8 times time. Divide both sides by negative 9.8. Time equals about 2.04 seconds. So, it takes just over 2 seconds for the ball to reach its highest point. Problem 3. A train accelerates from 5 meters per second to 25 meters per second over a distance of 150 meters. What is its acceleration? Initial velocity is 5 meters per second. Final velocity is 25 meters per second. Displacement is 150 meters. We're solving for acceleration. Time isn't given, so we'll use the equation. Final velocity squared equals initial velocity squared, plus 2 times acceleration times displacement. That gives us 625 equals 25 plus 300 times acceleration. Now subtract 25 from both sides. 600 equals 300 times acceleration. Divide both sides by 300. Acceleration equals 2 meters per second squared. Problem 4. A cyclist speeds up from 4 meters per second to 10 meters per second over a period of 6 seconds. How far does the cyclist travel during this time? Let's start by identifying what we know. Initial velocity is 4 meters per second. Final velocity is 10 meters per second. Time is 6 seconds. We're looking for the total distance traveled, the displacement, during this period of acceleration. Now here's the key idea. The cyclist is not moving at one constant speed, but gradually speeding up from 4 to 10 meters per second. So instead of using a single velocity, we take the average velocity over the 6 seconds. That's why we use this formula. Displacement equals the sum of initial velocity and final velocity, divided by 2, then multiplied by time. It gives us displacement when an object accelerates uniformly, by multiplying average velocity by time. Now let's solve it step by step. Add the velocities. 4 plus 10 equals 14. Divide. Finally, multiply by time. 7 times 6 equals 42. So, the cyclist travels 42 meters over 6 seconds while accelerating. Thanks for watching. Now that you've seen how the constant acceleration equations work and how to apply them, you've taken a big step in mastering motion. If you watched our last video, you now know what acceleration really means, and this lesson builds right on top of that. If you haven't seen it yet, go check it out, because once you understand that concept, these equations make a lot more sense. And don't forget to like, comment your questions, and subscribe for more physics explained simply.